Okay, so this is a video response for assignment 5F1. Thank you very much for your email requests. I've got them all right here. We're going to do problem number 1 the whole way through, and 4, 6, 27, and 28. Here we go. Fortunately, so it might feel you might feel a bit overwhelmed right now because you're not getting any of these problems. I want to say that the good news is that they're all very similar. So if you didn't get it for problem number 1, you might not be getting it for problem 2, 3, 4. But as soon as you get it for problem number 1, then all the rest of them should be fairly similar. So let's dive right into it. Problem number 1 asks, it gives you this formula for millions of compact discs being sold in years after 1985. Well, you and I both know that comically, this trend didn't completely continue. In fact, compact discs are almost dead. No one's buying them at all. It's not exponentially growing. You're going to see how old this textbook really is. Let's get started. We want to know the time when N of t has an output of 1,000, and you might say, Mr. Bergman, what if it says 1 billion in the textbook? And I know it does, but remember, N is in millions of disks, so 1,000 millions is a billion. Your output is 1,000. You put that over here, and then you get 7.5 times 6 raised to the 0.5t. And then we have to undo these operations until eventually we get to t. We undo the multiplication with division, dividing both sides by 7.5. You can take the log of both sides to get t all by itself. Remember, the log of this, when you take the log of the right-hand side, this exponent becomes multiplication and moves over here to 0.5t times log of 6. So you have something is equal to another thing times t times another thing. You can divide both sides by 0.5 and by log of 6, and that's how they get to the denominator here, this fraction. Type all that into a calculator, you get about 5.5 years, and that's 5.5 years after 1985 would be about 1991, which might have been true back then, but you certainly can't continue the pattern today. Doubling time, there's a couple ways of doing this. I should say there's actually a couple ways of doing 1a as well. You could have rewritten this equation, for example, it is an exponential equation. You could have written it as a log of base 6. You would have gotten the same answer also. But there are two ways of doing this. I think the easiest way to do it would be to figure out what is the output when the input is 0, like when the time is equal to 0, how many compact discs are they producing at the very beginning in 1985, and that's 7.5 million. Double that to 15, and so then you have to figure out when is at what time are there 15 million discs being produced. So you plug in 15 over here, and then again divide both sides by 7.5. Again, take the log of both sides. Again, the exponent moves from 0.5t over to the front. Divide both sides by 0.5 and log of 6. You actually get the same exact thing. You have to type into a calculator log of something over 0.5 log 6. And you get an answer of 0.77. That is the answer. 0.77 years is the doubling time. Every 3/4 of a year, it's going to double in production. Alternatively, you could have taken your answer from A, like if you know that it takes, if you want to know how long it'll take to go from 1,000 discs to 2,000 discs, then we know already it takes 5.5 years to get to 1,000. How long will it take to get to 2,000? So 2,000 here. Again, divide by 7.5. Again, take the log of both sides. Again, the exponent moves out front. Again, you divide both sides by 0.5 log 6, and you get 6.2. So to go from, at time equals 6.2 years, it will be doubled from when it was 1,000. So 6.2, the amount of time that elapsed between your answer to part A and double that of A would be 6.23, that's this answer right here, minus 5.46, and you get about 0.77. All right, we're going to keep on going here. We're going to solve this in very similar ways. They give you a formula, they give you the output, you have to find the input, which is time. So that's why 60,000 goes over here, and you have the rest of the formula. Dividing both sides by 250,000, you get this. Taking the log of both sides, you get this. And then recognizing there's an exponent inside the log, and it becomes multiplication outside of the log, you get this. Dividing both sides by log of 0.25, you get this. typing it into a calculator, you get this. So the answer is after about 1 year. What if the output value was 10 cans in circulation? Again, divide, take the log of both sides, move the exponent out to the front, dividing both sides by undoing this multiplication here by dividing both sides by log 0.25, and you get this. And let that equal about 7.3. When you type that into a calculator, it's about 7.3 years. Next, problem number 6. They give you a formula. The output is 20. Same thing. You put 20 on the outside, and then undo this multiplication by dividing. Take the log of both sides so that you have this, and then an exponent inside the log becomes multiplication outside the log. Dividing both sides to get t all by itself, you get this, and that's about 59. 1937 plus 59 years is 1996. Then, to find the doubling time, I think it's easier to find, just start with 0. When t is equal to 0, you have 2.3 pounds. That's just kind of your starting value. So how long will it take to double? You double it up to 4.6 pounds, and then solve for t. You solve for t by dividing both sides by 2.3. This is not an accident. This 2 is here because it's doubled. You're finding doubling time. Notice it stays here log 2, and then even here, when you're finding doubling time again, at log, the 2 is still here in the answer, or in the last step, because you're finding doubling time. So you can expect there to be a log 2 when you're doing doubling time. The exponent moves out front, and then you undo the multiplication by dividing both sides, and you get 9.1 years. The formula here for number 27, here they give you the formula, and if the output is 100, what is the time? So 100 words per minute. Put it out here, divide both sides by 200, and then there was some more work I could have shown here. You can subtract 1 from both sides to get negative 0.5, and then multiply both sides of the equation by negative 1 to clear this negative, and then you get 0.5 is equal to 0.86t to raise the t power. Now here, if you wanted to, you can take the log of both sides and then move the t out to the front, just like we did over here. But I find it, I just wanted to show you this is an alternate way of doing it. You can rewrite this exponential equation into a logarithmic equation, where the base is 0.86, the power is 0.5, and the exponent is t. T is equal to log base, not 10. I mean, all these are log 10s, but this is log base is 0.86 of 0.5, which is kind of a weird expression to think about. But you can use the change of base formula. Now these are log base 10s, log base 10 of 0.5 and log base 10 of 0.86. Looks very similar to what we have over here, so just in format. Anyway, you type that into a calculator and divide it by, and you get 4.6 hours. You're going to do the same thing again here, and you're going to get 150. Dividing both sides by 200, you get 0.75. Subtracting 1, you get negative 0.25, and then multiplying both sides by negative 1, you get positive 0.25 here is equal to that. Again, taking the log, changing this exponential equation to a logarithmic equation, you get all that, and the change of base formula allows you to do this, 9.2 hours. Number 28. Here you can see there's a formula, and some people asked about this formula. It's an interest formula. So P is $100,000. That's what you start with. That's your principal investment amount, and then you're getting 8% quarterly. That means that they're going to pay you 8% over the course of an entire year, and give you interest on it 4 times. So the I is 8%, and we can input that as 0.08 here, and the N is 4, because quarterly is how many times you're going to get it. You're going to get 4 times a year. So when you put those things in, you get this formula, and actually you can have this as your answer, and that'd be fine. I'd mark this correct on a quiz or something like that on a project. But you can also simplify what's inside the parentheses to get 1.02 here, and maybe that's a little bit easier to type out and use. That's what I'm going to use for the rest of it. This is the version of this answer I'm going to use. Anyway, 1 million is they want to know when you're going to have a million, and then so you divide 100,000 both sides by 100,000, and you get 10 on the left-hand side is equal to this. Take the log of both sides, move the exponent out, you get 4t. Oh, by the way, log of 10 is 1, just like log of 100 is 2, log of 1,000 is 3, log of 10 is 1. Divide both sides by log of 1.02, and you get this, which is about 29 years. Here, do the same thing. The doubling time would be, you have a 2 over here. I mean, this is how many times it'll take to multiply by 10. So how long will it take to increase by tenfold? You put a 10 here, and if you want to know what the doubling time, replace the 10 with a 2. So then you got 2 is equal to 1.02 raised to the 4t, and then you can take the log of both sides to move the exponent out to the front. Log of 2 is equal to 4t times that. Dividing both sides by 4 and log of 1.02, type it into a calculator and get 8.8 years. Hope that's helpful. See you later.